Eaton Antilock Braking system brings a vehicle to a stable, steerable stop in the shortest distance possible by sensing wheel speeds and modulating the brakes at the individual wheels. ABS can actually reduce stopping distances because the driver doesn't have to vary the pressure on the brakes to prevent wheel lockup. The driver still has to watch out for trailer lockup unless, of course, the trailer is also equipped with an ABS system. In the cab, things aren't much different. There's an ABS lamp and a diagnostic switch, whose operation is straightforward. The only significant difference is the added control the driver will come to appreciate at the next hard stop. It's as good and simple as that. Okay, let's take a closer look. First, let's go through individual system components. The brain of the system is this electronic control unit, or ECU. The ABS lamp is typically clustered with other lamps, and the system diagnostic switch, which could also illuminate, is normally located near the driver. Lamp switch and ECU placement will vary depending on the OEM. Check your owner's manual for exact location. ABS sensors tell the ECU how fast the wheels are turning. They work like a tach or road speed sensor. A pulse wheel like this, mounted on the hub, spins past the electromagnetic sensor, producing an AC voltage that's processed by the ECU. The frequency of the pulses indicates the speed of the wheel. There are typically 4 such sensors, 2 on the steer axle and 2 on the drive axle, most likely to skid. This really depends on the type of suspension, but in most cases, you'll find the sensors on the rear drive axle. The pulse wheels are attached to the wheel hubs, and the sensors are mounted in blocks attached near the brake backing plate spider. The ABS installation only slightly changes the basic service brake system, and it is important to note that even with these changes, the front and rear standard service brakes remain isolated. There are 4 pressure modulation valves. During ABS braking, the system ECU rapidly cycles the valves through different modes: pressure increase, pressure decrease, and pressure hold to control wheel speed. The vehicle operator controls the maximum amount of pressure applied to the brakes through the force on the pedal. Note, pressure to the brake chamber can never be more than what the operator asks for with the foot pedal. Typically, the left front and right front valves are located between the quick release valve and the respective air brake chamber. The right rear and left rear valves are located between the relay valve or brake proportioning valve and the service chambers. So here's how it all works together. At startup, the ABS lamp should come on with other warning lamps as part of the routine bulb check. If it doesn't go on, you have a bad lamp and the bulb must be replaced. During this time, the ECU checks the system, and if everything is in place and working properly, the lamp will turn off. However, if the ECU detects a problem, the warning lamp will stay on. This indicates that a failure has occurred within the ABS system. This failure could be intermittent or continuous, and depending on the nature of the failure, all or part of the system will shut down and automatically revert to conventional braking. If the failure is only in part of the system, the rest of the system will keep functioning and continue to give some anti-lock brake control. On the road, the speed sensors are constantly sending wheel speed information to the ECU. When the driver pushes on the service brake, air goes through the pressure modulation valves to the service brake chambers, just like a truck without ABS. As the wheels slow, the ECU monitors each wheel's speed. If one or more wheels slows too fast, the ECU directs the pressure modulation valve to hold the pressure in those chambers. If a wheel begins to lock, the ECU controls air pressure in the brake chamber as necessary to optimize braking. If a tractor is equipped with an engine retarder, it will be switched off when ABS is activated. All this happens in fractions of a second. Like the air brakes themselves, the ABS has been designed as a dual system with a safety redundancy built into the ECU to protect the driver. The 2 halves of the system are called diagonals. The diagonals split the ABS system, so there's always ABS on opposing sides of the truck, even if one side is shut off. One half controls diagonal 1, the right front and left rear chambers. The other half controls diagonal 2, which includes the left steer axle brake and the right rear tandem brakes. If one diagonal fails, the remaining diagonal still gives the driver some ABS control. And if the entire ABS system fails, the system simply acts like a regular braking system without ABS. Now that's worth repeating. Note, failure of the ABS system does not affect the basic service brakes. There are two related systems we need to review. The first, automated traction control, or ATC, is often included as an option with Eaton ABS. The second is Eaton's trailer-mounted ABS product. This independent system works in much the same way as Eaton tractor-mounted ABS. Eaton Automated Traction Control is a natural extension of Eaton ABS in that it uses the same sensors and valves, and its logic is contained in the same ECU. The only additional component in the Eaton ATC system is a traction control valve. The ECU directs this valve to apply pressure to the relay valve and provide differential or side-to-side braking that slows the slipping wheel while allowing the wheel with greater traction to develop torque. As it does, the ECU protects the brakes from overheating by continuously calculating brake temperature. The Eaton ATC system provides three modes of operation. A low-speed mode, where both engine and brake control are used to enhance vehicle traction. A mud and snow mode, where the ECU allows more engine power and wheel spin when it senses a less tractable road surface. And a high-speed mode, where the system acts only to throttle back the engine to control wheel spin. In the cab, you'll find a separate ATC lamp, which turns on with the ABS lamp and other lamps at ignition. Again, if it doesn't go on, you have a bad lamp and the bulb must be replaced. If the vehicle is equipped with traction control, the ATC lamp will remain on until the driver pushes the brake pedal. If the ECU detects a problem with the ATC system, it illuminates the ABS lamp. Remember, Eaton ATC is a subsystem of ABS. We'll discuss what to do in a few minutes. The lamp flashes rapidly whenever the system is operating in the high or low speed mode. It flashes slowly when operating in the mud and snow mode. Note, some vehicles equipped with Eaton ABS but without ATC use the ATC lamp to signal a slip condition. The lamp will flash to indicate the condition to the driver, but no traction control is provided. The second related system is the Eaton Trailer ABS. This system uses the same kind of sensors as the tractor-mounted system, along with solenoid-controlled relay valves to control brake pressure. The number and position of each component varies with the manufacturer. See your OEM service manual. Like Eaton tractor-mounted ABS, should any component fail, the driver is warned and the system shuts down to allow trailer control through conventional braking. Now let's move on to troubleshooting. And with Eaton ABS, you'll find most of it takes place comfortably from the cab. The ECU is programmed to recognize the parts of the ABS system installed in the truck, what's called the system configuration. It then constantly watches how well the entire system is working. Whenever the ECU identifies a problem, it selects a fault code that describes the problem and turns on the warning light. When the driver turns off the ignition, any fault codes are stored in memory until the system is reset. This allows the technician to retrieve these fault codes as blink codes. Reading the blink codes is simple. Turn on the ignition. If the vehicle is equipped with automatic traction control, apply and release the brakes once before proceeding. Now press and hold the diagnostic switch for at least 1 second, but not more than 3 seconds. That is, press and hold the switch while counting 1001, 1002. Shortly after you release the switch, at least one blink code will always be displayed. If there have been no problems with the system, you will receive a no faults code consisting of a blink, a short pause, and a second single blink. All blink codes are displayed in the same fashion, what we call two-block codes. There can be several blinks per code, so be sure when you are ready to retrieve blink codes, you have a paper and pencil to write them down. Okay, now let's retrieve the blink codes for a vehicle whose ABS system had some problems on the road. Start by turning the ignition key to on. Again, if the vehicle is equipped with ATC, apply and release the brakes. Press and hold the diagnostic button, counting 1001, 1002. With paper and pencil in hand, write down the codes. Let's see. 1, 2, 3, 4. 4 blinks in the first block. And 1, 2 blinks in the second block. Now be sure to wait and watch for other codes. A 4 to 5 second pause separates each code. Okay, 1, 2, 3, 4, 5 blinks in the first block, and 1 blink in the second block. Any more codes? None. So we have a 4-2 blink code and a 5-1 code. By the way, if you make a mistake during one of these steps, simply start over by pressing the diagnostic switch and proceeding from there. The next step is to clear the blink codes, which accomplishes 3 critical tasks. First, clearing the codes automatically determines if any of the codes you wrote down were triggered by intermittent faults, that is, problems that may have occurred but are no longer active. Things like loose connections or broken wires that have been serviced or components disconnected and then reconnected during vehicle maintenance. Intermittent faults are rare, but they happen, and it's good to record them. However, when clearing the codes, only those codes signaling an active ongoing problem will be reported, and that saves unnecessary work. Second, clearing the codes provides an opportunity for you to check your work, to make sure you recorded the codes correctly the first time. That can also save time and cost. And third, clearing the codes resets the ECU memory and provides a clean start for the next duty period. To clear the blink codes, turn the ignition key off. Then press and hold the diagnostic switch while turning the key to on. Wait 2 seconds and release the switch. Press and release the brake pedal. Conclude the sequence by repeating the code retrieval process. You should only receive a 1-1 code, indicating no trouble found. If you receive any other codes, write them down and proceed with troubleshooting the faults as described in the service manual. We'll discuss how to do this in just a moment. Now, how about the Eaton trailer-mounted system? An ABS warning light on the driver's side of the trailer signals any failures in the system. It also serves as the system blink code lamp. Retrieving the codes is straightforward. First, power the trailer. If the trailer is unhooked from the tractor, use a battery or power source other than a battery charger. Next, connect the Eaton blink code adapter to the data port under the trailer. This jumps pins A and E on the data port, forcing the warning light to come on. After at least 1 second, remove the adapter. The ABS light will now begin to blink the codes. To clear the codes, install the blink code adapter on the data port. Power up the trailer. Wait until the warning lamp goes out and then back on for at least 1 second. Then remove the blink code adapter. You should then receive a 2-block code. The first block indicates the configuration of the trailer ABS system. The second block should be a single blink, indicating no trouble found. If you receive any other codes, write them down and proceed through the troubleshooting section of your service manual. Now, what do the blink codes mean, and how do you service the faults they may indicate? No problem. For every blink code, there is a fault code listed in the Eaton ABS service manual. They are categorized by component areas of the system. This listing cross-references to more specific conditions and actions to remedy each fault. A glossary of terms is also included in the guide. If you have any questions after consulting these references, call your Eaton Road Ranger at 1-800-826-HELP. He's there for you 24 hours a day. It's the difference between buying Eaton and buying anything else. Let's work through what we must do to remedy a problem found. We'll use our earlier examples. First, blink code 42 indicates that either the air gap is too large at the left rear sensor or that the sensor has shorted. The guide provides general instructions and information, in this case, the location of the sensor and what to do to fix the problem. Likewise, let's work through fault 5.1. Looking in the guide, we find the code indicates that there's too large an air gap for the right rear sensor. It then directs us to further instructions. Eaton ABS comes in a variety of configurations, depending on the components on the vehicle. If you need to know the configuration, you can retrieve it using the blink codes. Here's how. Turn the ignition key to on. Press and hold the diagnostic switch for at least 1 second, but less than 3 seconds. Again, counting 1001, 1002. Release, then quickly depress the diagnostic switch a second time. Count 1001, 1002. You will now receive a 4-block blink code. Write it down. Here, it's 1215. Now refer to your service guide. A blink code of 1215 tells us the ABS system is configured to operate with 12 volts, has 4 sensors and 4 modulation valves, that an engine retarder is not configured into the system, and that the system also includes automatic traction control using both engine and brake control. The manual provides schematics and configurations of sensors and actuators. If you like, you can also use diagnostic tools like this ProLink 9000 to identify problems, as well as obtain other information on tractor-mounted ABS systems without working with blink codes. This unit, along with a cartridge specifically programmed to interpret signals from the Eaton ABS ECU, is available from its manufacturer, MPSI. Simply hook the diagnostic tool to the industry standard data port inside the cab. Then scroll through the menu options to obtain the information you seek. Selections on the ProLink include system information, fault codes, monitor data, component test, system setup, end-of-line tester, ATC off, a choice for English or metric, and exit. A summary of these menus is included in your Eaton service manual. Additional information is also available from MPSI. Now let's look at ABS troubleshooting from a different perspective, a hands-on perspective. Whether you're dealing with a tractor-mounted or trailer-mounted system, ABS troubleshooting is pretty straightforward. In general, there are only 4 things that can go wrong. 1, the sensors could be out of adjustment, broken, or their wires damaged. 2, there could be a problem getting electric power to the system. 3, the wires running to the pressure modulation valves could be damaged, or a pressure modulation valve itself could be faulty. And 4, the ECU could fail. That's pretty much it. Let's start with the sensors, which can either go bad or become misadjusted. There can also be problems with the connector or the wiring harness. How can you tell the difference? Run the diagnostics. On adjustment problems, the sensor is supposed to be almost touching the pulse wheel all the way around the wheel. This adjustment may be hard to see, especially on the drive axles. But adjusting the sensor is easy, and you don't even actually have to see the gap. They more or less find the correct distance themselves. Simply push the sensor till it actually touches the pulse wheel. Don't use a hammer or other tool. If the sensor is on a drive wheel, you may have to remove both wheels and the inner brake drum to position the sensor. While you're there, inspect the sensor for obvious damage, including the wires and connectors. If it was misadjusted, something moved the sensor out of position. They don't tend to vibrate loose by themselves. A likely cause of the gap might have been too much wheel bearing play. That's a simple adjustment we're all familiar with. In fact, any time you work on the hub or bearings, be sure to readjust the sensor. After the adjustment has been made, clear the system and take the truck for a test drive to confirm that the problem's been corrected. Note, with sensor repairs, the warning lamp remains on even after a repair until vehicle speed reaches about 4 miles per hour. It should then go out, indicating that the sensors are working. Now, what if the codes indicate an electrical problem? That means that there is no signal from the sensor itself. In this case, remove the retaining clip and disconnect the sensor. Then use the long probes with your multimeter to measure the resistance across the two contacts. Wiggle the sensor cable to check for intermittent contact. Your multimeter should read between 950 and 1900 ohms. If the sensor is good, reconnect it and test the sensor circuit resistance at the ECU connector. First, make sure the ignition is off. Then disconnect the ECU and identify the connector pins for the sensor using the diagram in your Eaton service manual. If the resistance is off, the problem is most likely the harness. But let's just suppose that the sensor is bad and needs replacing. The procedure is straightforward. After removing the old sensor, lubricate the bore, then insert a new friction sleeve into the block. Next, insert the new sensor. Adjust it so it touches the pulse wheel. Now reroute the sensor wire. Reinstall the retaining clip and reconnect it, tie wrapping the connector to the retaining clip. Finally, double-check to make sure the sensor is adjusted. Now go back into the cab and clear the codes, and take the truck for a run. Check to see that the warning light does not come back on, and when you return, double-check the diagnostics to make sure there were no faults recorded. Now let's move on to the pressure modulation valve. As with the sensors, a problem with the pressure modulation valve could be in the valve itself or in the wire connecting it to the ECU. Let's start by testing the valves. Each pressure modulation valve has two solenoids that control air to the brake chamber. They must each be tested. To do so, remove the connector and measure the resistance between pins 1 and 2 on the pressure modulation valve. It should read between 3 and 6 ohms. Pin 1 is the closest to the inlet port, and pin 2 is the next pin clockwise. Then test between pins 1 and 3. It should also read between 3 and 6 ohms. If the readings are out of spec, you must replace the unit. There are no repair procedures for these valves. Replacement is straightforward, but remember to chock the truck and drain the air system before removing any air fittings. And be sure to clear the codes when you finish making the replacement. If the valve tests good, reconnect it and check the wires from the valve to the harness connector in the cab, as you did with the sensor. The wiring diagram and connector drawing in your Eaton ABS manual identifies the correct pins. Of course, the last step is to clear the codes and take the truck for a test drive to check the system out. Again, check the warning light and for fault codes when you return. Okay, let's troubleshoot the ECU itself. It's pretty straightforward. The problem could be the power supply or the unit itself. Troubleshooting simple electrical faults in the power supply is something that you should be familiar with. Use your meter to check three things at both the main fuse relay panel and the connector on the front of the ECU. 1. Is there power to the unit? 2. Is the voltage between 10.5 and 14.5 volts? And 3. Is the ECU properly grounded? If the codes indicate there is an internal problem with the ECU, you must replace the unit. But don't replace an expensive ECU until you try reconfiguring the system and the same code reappears. Replacing an ECU is simply a removal task, but there are two ways that you could damage it yourself. 1. Never attach or detach the ECU connector when the ignition is on. Note, always power down the tractor or trailer while servicing any components of onboard ABS systems. And 2, always detach the ECU connector before you do any welding on the chassis. Actually, that warning goes for other electronic components like engine controllers as well. One last point. If for any reason you need to dyno test the drivetrain, you must first disable the traction control system. It's easy. First turn the ignition key to on. Press and hold the diagnostic button for at least 3 seconds and release. The ATC light will turn on and stay on. Also, you should receive a 2-block blink code of 17 and 8 blinks, verifying the ATC is disabled. At the next ignition cycle, the ATC system will automatically be reactivated. Eaton ABS is a dependable system providing a safer ride for the driver. and a safer road for everyone. State-of-the-art diagnostics make it easy to maintain, and your Eaton service manual tells you all you need to know. Plus, if you have any questions, your Eaton Road Ranger is just a phone call away. Eaton ABS, tractor and trailer systems. It's the complete package.